we'll use this class to talk about a very common design pattern called the iterator pattern. Now, this is one design pattern I guarantee that if you've used any programming language for any length of time, specifically languages like Python or Java, you've used the iterator pattern. Why am I so confident? This is because the iterator pattern is the underlying pattern behind loops such as for loops. And if you've written any Java program beyond the basic hello world, you've probably used for loop. So the thing is that iterator pattern is so ingrained in this concept of the ability to loop over lists or collections that we don't realize it's a pattern at all. However, it has a few interesting characteristics which is worth studying in detail, and we'll do that as a part of this class. The iterator pattern basically defines the ability to iterate or loop over collections. So before we look at the iterator pattern, let's take a brief segue into Java collections and all the classes associated in the Java collections framework. So firstly, we refresh our memory, and secondly, we understand how exactly the iterator pattern fits in. Java collections are pretty awesome. They completely change the way you interact with collections in any programming languages, and I think they are the bar for all modern programming languages. So what are collections? Collections are containers which hold collections of data. So you have one data element and a collection can hold a whole bunch of those data elements. Examples of collections are a list. This is a collection of values where the order matters. The first element in the list is the first element for some reason. The second is the second element, so on and so forth. And you can actually access elements at a specific position in a list. Lists are ordered collections. Another example of a collection is a set. A set is a collection of values where the order does not matter. It doesn't matter what order you've added it in, it has no significance. The most important thing in a set is that values in a set are essentially unique. When you have a set of values and you want to make sure that no value is repeated twice, you typically add it to a set which will take care of deduping these values. The next collection is a map. Here the collections are getting a little more complicated and more interesting. A map is a collection of key value pairs. So a map contains data in pairs where one is the key which indexes that data and the other is the value which is the value associated with that key. So typically you can look up values by specifying a key, or you can iterate over all keys, or you can iterate over all values in a map. You can also iterate over all entries in a map where an entry is defined as a key value pair. Alright, lists, maps and sets are all types of Java collections. In fact, Java has a whole bunch of inbuilt classes which offer you the functionality of lists, maps and sets. In fact, list, map and sets are Java interfaces, and they have a whole range of implementations behind each interface. We spoke about lists, maps and sets. In fact, the Java collection templated by T class is a generic interface that all of these collections implement. Whether it's a list, whether it's a map, whether it's a set, all of them implement the collection generic interface. That's kind of the building block around which all collections are built. It defines the basic collection contract. Now, Java also has this very interesting class called the collections class. Not to be confused with the collection interface or any of the other interfaces, the collections class basically has a whole host of static member functions that work on all collections. These member functions give you a whole bunch of interesting utilities like sorting, creating collections, so on and so forth. anything you want to do with collections, it's probably present in this collections class with all its member functions, static member functions. So 2 things for you to remember: the collection generic interface and the collections class. Both interesting and both very useful as we deal with collections. Now, what are the interesting utility methods that the collections class offers us? There are a whole host of them, useful to all programmers working with any type of collection. Generally, before you write something yourself, you should check whether the collections class actually offers you a way to do this. Examples are collections.sort, collections.shuffle, basically just randomize the elements in a collection, collections.reverse, if you just want to reverse the order of a list, for example, collections.min, find the minimum element in the collection where you can define what minimum is. Collections.max works exactly the same way except finds the maximum element. Collections.rotate. These are examples of things you could do with the collections class and its static member functions. Let's look at how the collection hierarchy is set up, starting with the base interface collection. Note that this base interface is actually generic, which means we can create any kind of collection, whether it's of strings, booleans, any objects that you've specified, so on and so forth. So we have the interface collection at the very top of the hierarchy, and all collections implement this interface. Whatever kind of collection you are, list, set, map, you implement the collection interface. The collection interface, in my opinion, defines the basic contracts that any collection has to follow. Now, we have another interface which inherits from collection. So it derives from collection, and it's the list interface. We've just discussed that list basically is an ordered list, where the order of elements in a list matters to you. So the list obviously has all the methods which collection has, thus adhering to the collection contract. It has additional methods which are specific to lists. So that is the list interface. Another example of a collection is the set. The set is also an interface as specified in Java. A set consists of unique elements where no element should be the same as the other. The set should do its deduping for you based on whether you specify 2 elements are equal. For example, if it's a user-defined class, you need to be the one to specify whether these 2 user-defined classes are actually equal. So that's the set interface. The third interface which derives from collection is a map. See, these are the basic kinds. There are others, and you could define your own user-defined interfaces which derive from collection. However, these are the basic fundamental building blocks which Java provides. The map, as we discussed, is a collection of key-value pairs. Key-value pairs allow us to associate 2 pieces of information together and indexing the second one using the first. This indexing allows us to look up values by specifying the key, and it proves extremely useful when we program. So these are the interfaces. Let's look at what implementations are specified for each of these interfaces. The first type of list, and the most commonly used, is an array list. An array list is an actual class which implements the list interface, which means that it also implements the collection interface, since list derives from collection. If you're using a list for the very first time, the probability is high that you're using an array list. An array list is simply kind of a replacement for arrays where a list can dynamically grow and shrink as you add and remove elements from it, which an array could not do. Another example of a list is a stack. This is a special purpose list. If you think about it, the way you operate with a stack is to add elements on the top of a stack and pop those elements out in the last in, first out order. A stack is also an example of a list. An example of a set is something called a hash set. A hash set basically hashes the elements in some way, figures out a hash or a unique representation for an element, and uses that to track unique elements in the set. So hash set is an implementation of set. And similarly, we have a hash map. A hash map basically hashes the keys that you pass in the map to enforce that there is just one key of a particular value. Keys in a map are unique. This is what allows us to look up elements in a map. We know that a key will be present only once. So a hash map is an example of a map. It's worth taking a minute, pausing and looking at this hierarchy. This is a key hierarchy which you'll use in Java development, and you should really understand how it's set up. We've given only one example of an implementation of a set and a map. This is just an example. There are a whole variety of sets and maps and even further kinds of lists, and based on the functionality that you want from that list and the special characteristics, you can choose which list you want to instantiate.